In this section, we introduce the initialization of controllers. First, we will introduce the basic terminology of SD-WAN. In the second part, we will discuss how controllers authenticate each other and integrate through certificates and a whitelist mechanism to authenticate and integrate with each other. First, let's look at the terminology of SD-WAN. The first is the distinction between Vedge and C-Edge. Generally speaking, we refer to C-Edge as Cisco's hardware routers. This is usually as our entire SD-WAN evolves. We expect to deploy our controllers and edge devices in the cloud and virtualized environments. Therefore, the virtual Cisco router is also known as C-Edge. Specifically, Vedge refers to the traditional factory-produced routers by Viptela routers. This includes vsmart, vmanage, and vbond, which are core components of our SD-WAN. Okay. Next, there will be a series of terms. They are very important. Let's look at the first one, transport side, which is very simple. We just need to think of it as a physical circuit. For example, our Ethernet lines, our MPLS lines, our LTE 5G lines. We can all consider them as transport, or say transport side, when deploying. By default, put the transport physical line in VPN. 0 regarding routers. It's actually a VRF here, VPN. From the router's perspective, it's a VRF. We emphasize this point. The second is the service side. We'll also make a simple summary of it. You can think of it as a logical line, or say a logical channel service side. We divide it into two main categories. The first category, its numbers range from 1 to 511. This part represents our specific business services. The second category, specifically reserved for 512, is for our controllers and our edge devices to use for OOB or MGMT management interfaces. These are the two main categories of services side. The third term is T-lock. Might seem very abstract, including some terms related to T-lock seem abstract. We also give it a simpler understanding. LOC is an abbreviation for location. So this location refers to positioning. Where is it positioned? Actually, it's positioned on our next hop router. We can consider transport positioning where the next hop is. This is clearer regarding two adjacent routers. They have private addresses or public addresses. Public addresses can be used for NAT to extend LOC for private addresses. This is the ultimate meaning of T-lock. T-lock often involves T-lock extensions. We often say T-lock extension means this. The fourth is Vout. This is virtualized routing. Actually, it's very similar to our traditional routing. We can consider it as a virtual router within which the routing is Vout. Specifically, this routing is conveyed through the OMP protocol. The OMP protocol is custom designed by Cisco for SD-WAN development. In a traditional sense, you can see it as a protocol similar to BGP protocol. Here, due to the limited content of the PPT, we can refer to some related documents, OMP protocol. Let's look at this diagram. This diagram includes vsmart 3 vsmarts, form an OMP session. Here are two vEdges, Vedge and vsmart, run the OMP protocol between them, as you can see. In fact, we can consider vsmart as the reflector in the BGP protocol. Okay, then it's very similar to BGP. The reflector reflects routes. It processes routes but does not generate routes. So, what routing information does it collect? It collects information from the edges and passes it between edges. Okay, please pay attention. Do these two edge levels have any connection? Edges do not have direct sessions between them. It is reflected through the role of vsmart. Okay, back to our PPT, we have a simple general understanding of the OMP protocol. Next, let's look at the site ID. Site ID is usually a string of numbers. We can easily refer to or invoke this number, similar to an access control list, for example, matching items to invoke to match the routes and policies we want to control. This is site ID is just a string of numbers system IP. In the past, when configuring traditional protocols, we would give it a routing ID. Actually, system IP is similar to this. It's somewhat similar to a router's ID. Please note, this ID must be unique in the SD-WAN domain. Its format is somewhat like an IPv4 address, but it is not an IPv4 address. It does not participate in routing. This is important to note, system IP. The next term is the organization name. Very important. Similar to the traditional sense of a name that can be resolved by DNS. We know that on the internet we use DNS to resolve a website or a site name. This site must be unique. Similarly, the organization name in our needs to be predefined when placing an order under sales, then defined and registered on Cisco's official website to ensure the organization name is without conflict. Thus, in Cisco's SD-WAN domain, it is conflict-free. Okay, after introducing these terms, let's review the small connections between them. We just mentioned the service side, site ID, and transport port. We consider physical interfaces, physical lines, MPLS internet, and for example LTE, as well as 5G lines. We can consider them as transport, our physical lines. Device VPNs range from 1 to 511 represent our internal business. They are isolated from each other. The third one is quite special. We do out-of-band management 512. This number will not change. VPN is also fixed, will not change. Okay, next, we officially introduce the initialization of controllers and how our controllers authenticate each other through certificates and a whitelist mechanism. Just now I introduced our three controllers, vmanage, vsmart, vbond. These three roles. When deploying controllers, their deployment environment is very flexible, commonly in ESXi environments. We can also deploy in KVM virtual environments. Now our public clouds like AWS, Microsoft Cloud, Alibaba Cloud in China, all support the deployment of vmanage, very convenient. If our enterprise has an OpenStack cloud, it can also support the deployment of vmanage. Regarding our logical devices, they have two interfaces. Note that interface 0 is always used for out-of-band management as the number 512. The first network card is placed in VPN 0. This is what we need to pay attention to when deploying vsmart and during the vmanage setup, alright? Because vmanage is a very important controller. To ensure its high availability, we need to set up a cluster. When setting up the cluster, there's a basic requirement in a virtualized environment. The basic requirement is to have a heartbeat line. Note, all three devices share a new VPN 0 as a heartbeat line for management to synchronize the databases of the three vmanagers Cisco recommends, and advises that when deploying a cluster, there should be at least three. At least three, and it must be an odd number. This is very important. In terms of our deployment location, we do not recommend spanning data centers. We deploy it within the same data center, deploy our cluster within the same data center. The communication latency within the data center should be less than 5 milliseconds. The requirement is very high. This communication, VPN 0, the minimum speed for these interfaces is a 1G line. This needs to be noted after we have deployed the cluster. For example, if we have 3 vmanagers, okay, how many edges can we manage? We say one can manage 2,000, 2 would be up to 4,000. Some might worry, don't I have a third one? Shouldn't it be 6,000? I'm sorry, that's not the case, okay? When one fails, sorry, that's not it. Okay, the 2,000 can be taken over by another V. Managed to achieve high availability and fault tolerance, realizing FT. This consideration is something everyone needs to be aware of. It's very important. And another scenario and another situation. Someone asked if 2 vmanagers can form a cluster. This is a question with 2 vmanagers. We can achieve high availability, or to put it another way of phrasing it, 2 vmanagers can indeed be used for high availability. Note it's high availability. So, the method for high availability is one hot and the other cold. It's essentially a cold standby, not a hot standby. For hot standby, the number of vmanagers must be odd, 3 or more. Okay, this diagram is very important. We have already introduced the role of vmanage. This diagram is very important. Let's look at the other 2 roles, vbond and vsmart. In our entire architecture, the role they play, vbond, in the entire architecture acts as an orchestrator, allowing our C edges to find our vsmart and vmanage. Just like when we access a website, we need to find the site. We rely on DNS. Here, our vbond acts like DNS. We can see our edge has configuration updates and routing updates that need to be forwarded through vsmart. This is a function of vsmart. Now let's look at the deployment of vbond. Similarly, VPN 5.0 is used for out-of-band management. The first network card is VPN 0. This is all fine. Deployment is very convenient, all in a virtual environment. It's worth mentioning that the vbond image, its ISO image is the same as our vEdge image, the same as vEdge, the same image for both roles. This is something everyone needs to be aware of. Okay, as we mentioned earlier, vbond is like DNS. And as we also mentioned earlier, vmanages HA, high availability, or in other words, the cluster in our entire environment. We can deploy up to 8 vbonds. We do not recommend exceeding this. The number of vbonds should be less than 8, as per the deployment conditions. As we mentioned earlier, there's a VPN 0. This VPN 0, it needs to have a 1.1 or 1-to-1 NAT address. It must be connected to the public network. Private addresses alone are not allowed. This is a mandatory requirement for the deployment of vsmart. The first network card, 512. The second network card is VPN 0. Similarly, it also has a requirement for high availability. Here, for high availability of vsmart, the number should also be advised not to be too many. Generally, we keep it below 8 to maintain its elasticity. Regarding what we just mentioned, the controllers can be deployed in our cloud environment and actually for the choice of cloud. We can directly use the cloud services of carriers, or we can build our own private cloud as an enterprise. The Cisco Cloud is also a paid service. The choices we make are relatively few. It is a chargeable service, so we have limited choices. Okay? Here, due to the limited content of the PPT, we also provide documentation and a summary for the controller initialization. This documentation and summary can also be provided to everyone. This part of the documentation can be easily made available for everyone to read. We selected from Cisco's official website content related to controller initialization. We'll review our controllers again, how they are initialized. We just didn't specifically emphasize certain aspects. From this control plane and data plane, let's analyze the controller initialization again. We didn't particularly stress several aspects from this control plane and data plane. Let's go through the controller initialization once more. The first is what's called the control plane. We mentioned earlier, the control plane involves our physical lines for vmanage, vbond, and vsmart. They are all the same. Control plane. Okay, after understanding the control plane, let's look at the data plane. The data plane is more about our edge devices, because we didn't specifically mention Vedge just now. So everyone should know that our data plane is located on our edge. Knowing this is enough. Next, we will review some of the terms we mentioned earlier. Transport refers to the physical lines we mentioned earlier. Service VPN is our logical business, a logical channel for our routers. In fact, it's a VRF. T-lock is the location of our transport. The location of our transport. We know it points to our physical next hop. This next hop can be easily marked with different colors for easy identification. For our policy, we can reference this color, for example, red, blue, yellow, to mark our lines. Site ID is a string of numbers. VRoute is the route reflected by OMP. Looking at this diagram, if you want to understand OMP, just remember this diagram. It's very similar to the operational principle of BGP, including the OMP selection rules, which are very close to BGP. The organization name is related to Cisco's cloud service, and it must be unique within Cisco's SD-WAN domain. Deployment of vmanage, besides the interfaces we focus on. Okay, we also mentioned some basic information related to the deployment, such as the system IP and the site ID. These are things we need to plan in advance when deploying vmanage, including the IP of vbond and similar information. IP and the site ID, understanding the site ID and organization name. These are all aspects we need to plan in advance when deploying vmanage. Of course, this includes the IP of vbond and similar elements. Regarding the physical deployment in a VM environment, we just need to import the OVA image. The BA image can complete its deployment. Okay, next, let's make a brief summary. After we have deployed the vmanage, vbond, and vsmart images in a VM environment, they are actually in a zero trust environment. How to integrate? Two important factors. The first one is certificates. The second one we call the whitelist. This whitelist is configured by the vmanage administrator through the graphical interface of vmanage. These certificates also have different channels and sources. The first type is an inbuilt certificate from Cisco. Then you can also set up a certificate environment within your own enterprise. The third type can actually be purchased. Through the whitelist and certificates, we authenticate each other and establish a DTLS tunnel. Here is the process of establishing a DTLS tunnel. Okay, everyone should study this process in detail after the class. Let's describe these 5 major steps. The first important step is mutual authentication through certificates. That's the first step. Verification by vbond. Verifying what? First, vbond also verifies the root certificate. Second, what does it verify? The whitelist. 2 things. vbond. Both of these things need to be verified. While verifying with vbond, it also checks our OU. What is OU? It's the organization name we just talked about. The name must be the same organization name to pass the authentication. First, to be precise, this is actually the third step. The fourth step is the authentication of vsmart. vsmart similarly verifies vbond certificate and also checks the OU name. These are two checks by vsmart. Once vbond and vsmart have both completed their verifications, our DTLS is established. This is the interaction process of DTLS. Subsequently, we have the initialization of the edge. We will introduce edge initialization in detail when we talk about edge, a detailed introduction. Okay, today we spent some time introducing controller initialization. After this class, we will provide the process of installation in a VMware environment to everyone. You can follow this process for hands-on experiments. That concludes the content we discussed today.